Question 2. Without using a calculator, find the value of sine of 240 degrees times cos of 210 degrees minus tan squared of 225 degrees times cos of 300 degrees times cos of 180 degrees. Reduction formulae are also useful when we need to simplify functions without using a calculator. We are asked to use no calculator to find the value of this expression. We're going to reduce each of these angles using our Cartesian plane and putting the trig ratios in the right quadrant, and also using our formulae for reduction. First thing we do is draw up a representative Cartesian plane, and that's going to help us with our sines. Remember that all the angles in the first quadrant are less than 90 degrees. All the angles in the second quadrant are between 90 and 180 degrees, and of course the third quadrant angles are between 180 and 270 degrees. Finally, in the fourth quadrant, your angles are between 270 and 360 degrees. Also remember, your cast diagram is very useful when determining the sines as you move around your Cartesian plane. So we need to reduce the value of sine 240 degrees. Something that's also useful in this section is special angles, so we're going to try and reduce all of these to special angles where we can. 240 we know is an angle that lies between 180 and 270 degrees. Therefore, it's going to be 180 plus some acute angle. 240 is the same as 180 degrees plus the special angle 60. So we can write 240 degrees as 180 plus 60 times cos of 210 degrees. 210 can be written as it's in the third quadrant, so it's 180 plus the special angle of 30 degrees. And then we've got minus tan squared of 225. 225, once again, is in the third quadrant, and we know that tan 225 can be written as 180 plus 45 degrees, which is another special angle, times by cos of 300. 300 is in the fourth quadrant, so we can write 300 as 360 minus 60, and then that's multiplied by cos of 180, which we can rewrite as cos 180 plus 0. So let's put all of this now onto one line using our reduction formula. So when I want to reduce sine of 180 plus 60, I first look at the bracket to determine which quadrant that it's in. That is 180 plus, which is the third quadrant. Therefore, I know that my ratio sign will be negative in that quadrant. So we just get negative sine 60 as the first term in the expression. That means we've got minus sine 60 by cos. We look at 180 plus 30. That tells us that it's in the third quadrant, so therefore cos is going to be negative in the third quadrant. So it's times negative cos of 30 degrees minus tan squared 45. The ratio will be positive. Every square will stay positive. Cos of 360 minus 60 will be in the fourth quadrant. Cos in the fourth quadrant is positive, so it's just times cos 60. Times by cos of 180 plus 0, that's in the third quadrant. So therefore this will be negative cos of 0 when we reduce it. Now that we've reduced everything to special angles, 30, 45, and 60, we can simply fill in these ratios. So, minus sine 60, using your special angle diagram, you'll get, firstly, let's work out our sine. A minus times a minus is a plus. Sine 60 is the square root of 3 over 2 times by cos 30, which is also the square root of 3 over 2, minus tan squared 45. Tan of 45 is 1. So you're going to square 1 times cos of 60, which is a half, times by negative cos of 0. Cos of 0 is 1, and negative 1 times 1 is just negative 1. So all of this we did by only using our special angles. The square root of 3 times the square root of 3 is just 3. 2 times 2 is 4. So our first term simplifies to 3 over 4. A minus times a minus is a plus. Our middle sign is a plus. 1 squared is 1. 1 times a half is a half. So you have 3 over 4 plus 1 over 2, finding a common denominator of 4. So you can simplify it all to 5 over 4. As you see, this long expression with all of those angles reduces to a simple ratio of 5 over 4. All we used here was not a calculator, it was reduction formula, and we also used special angles.